Heating with humidifying. In heating with humidifying, the air will pass through the heating section before it then passes through the humidifying section. In heating section, there will be heating coils, and in humidifying section, we are going to have humidifier where the hot steam will be injected through our channel. There will be three states in heating with humidifying. Process 1 to 2 will be the heating process, and process 2 to 3 will be the humidifying process. During the heating process, the specific humidity will be constant, while for humidifying process, the specific humidity will be increased. If we draw heating and humidifying to the psychrometric chart, process 1 to 2 is the heating process, where we are going to get increment to the temperature, while the specific humidity will remain constant. From state 2 to state 3 is the humidifying process. After the air passes through the humidifier, it will increase the specific humidity. In order for us to perform mass and energy balance, we are going to divide into heating section and also humidifying section. First, let's look at the heating section. For the mass balance for the dry air, we are going to get mass flow rate of the dry air at state 1 will be equal to the mass flow rate for the dry air at state 2. Thus, we can assign it as m dot A. For the mass balance for the water or vapor, we know that the mass flow rate for the water vapor at state 1 is equal to the mass flow rate for the water vapor at state 2. Since the specific humidity is equal to mass flow rate of the water vapor divided with the mass flow rate of the dry air, we can substitute this expression to the mass balance of water or vapor. Therefore, we are going to get this expression. Note that specific humidity for state 1 will be equal to the specific humidity at state 2. We know that during heating process, the air will flow through our heating coils and the heat will be supplied to the channel. The energy balance for heating process is given by the summation of the energy in equal to summation of the energy out. What's coming in to our system is the air and the heat, and what's leaving our system is the air. It is actually came from our steady flow energy equation. Heat exchanger, which representing the heating coil, did not produce or consume any power. Therefore, the terms power can be cancelled. Usually, we can neglect the terms kinetic and also potential energy. And in heating process, the heat is being supplied to our system. Therefore, the terms Q dot out can be neglected. Our steady flow energy equation will now become this expression. Note that we are going to use mass flow rate for the dry air during the air conditioning processes analysis. For humidifying section, the mass balance for the dry air is given by mass flow rate of the dry air at state 2 is equal to mass flow rate for the dry air at state 3. Again, we can assign it as m dot A. For the mass balance of the water or vapor, mass flow rate for the water vapor at state 2, referring to the air enters the humidifying section. m dot W is referring to the steam that is being injected by the humidifier, while m dot V3 representing the mass flow rate of the water vapor for the air leaving the humidifying section. Since we know that m dot v is equal to m dot a times omega, we can substitute to the mass balance for the water or vapor. Thus, we can get this expression. If we rearrange the expression so that m dot w will be the head of the equation, we can now have this expression. We can use this equation later to find m dot w. For the energy balance during the humidifying process, this representing the energy of flowing air into humidifying section, while these terms representing the energy of the steam supply to our humidifying section. Note that this energy are the energies that entering our system, and our system now is humidifying section. This term representing the energy of flowing air leaving our humidifying section. We can arrange the expression to this equation. Note that the enthalpy for the steam is equal to Hg at 100 degrees Celsius. 100 degrees Celsius is the saturation temperature at pressure equal to 1 atm. Therefore, it is advisable to you to read the question properly in order to determine which temperature the steam is being delivered.